Solving simultaneous equations graphically is not the most accurate method. Besides, is it time-consuming too? This is why we are looking at algebraic methods to solve simultaneous equations. There are two methods that we use, the substitution method and elimination method. Today we are going to look at how to solve simultaneous equations using elimination method. We are going to start with this example, and I will rewrite the equations one below other. So we are looking for two values x and y such that 2x minus y is 35 and x plus y equals 118. This method is based on the understanding that if 2x minus y is the same as 35, so these green boxes are the same for the values of x and y I'm looking for, and x plus y has the same value as 118, then when I add a green box with a blue box from the second line, I get the same as when I add the green box on the right hand side with a blue box on the right hand side. So these two blocks together are the same as these two blocks together. So if I add this together, will be the same as these two together. So let's do that. I can therefore write that. I write again the system, 2x minus y equals 35. Just to see it better, I copy again. X plus y equals 118. When I add the elements in the left hand side, 2x plus x will give me 3x. Minus y plus y will give me 0. And when I add the elements on the right hand side, I'll get 153. So let's repeat. I added equation 1 and equation 2. When I add the left hand sides, I get 3x. When I add the right hand sides, I get 153. This allows me, because I have a single variable, when divided by 3, to write that x equals 51. Now I substitute x to find y. I substitute x into equation 2 seems simpler. So I get 51 plus y equals 118. Subtract 51 from both sides. Therefore, y equals 67. So my solution is x equals 51, y equals 67. I need to check by substituting both into the first equation, which is 2x minus y is 35. So if I calculate the left hand side with my calculator, I see that I get 35. And the second one is x plus y equals 180. Second one is correct as well. So this is my solution. This method was called elimination method because after adding the two equations, I eliminate y. So y disappeared after adding the two equations. Let us try to solve this system of simultaneous equations. Again, I'm writing to write one below the other. Equation 1, equation 2. Very interesting, when I add the two equations now, I see that x will disappear. Minus x plus x will give me 0. And I will be left with 3y. So my second equation will be, my resulting equation will be 3y equals 9. I divide by 3. So I'm going to get y equals 3. I substitute y equals 3 into, it doesn't matter, but it seems that the first one is simpler, and I get minus x plus 3 equals 4. take away 3 from both sides. So I get minus x equals 1, multiply by minus 1, minus x times minus 1 gives me x equals negative 1. So my solution is x equals negative 1, y equals 3. I will check my solution. Replace into the first, minus x. If x is negative 1, minus x is 1. Minus x plus y equals 4. Correct. X plus 2y equals 5. Correct. Let us now look at this example. I rewrite the equations one below the other. So x plus y equals 5. 6x minus 3y equals 3. Equation 1, equation 2. If I add the two equations, I will have a surprise, because I get x plus 6x gives me 7x, y minus 3y gives me minus 2y equals 8. So I didn't solve my problem, because I am left with one equation but with both unknowns, x and y. In my previous cases, one of the unknowns eliminated. It doesn't eliminate here, therefore that's not a good solution. What I can do, after I analyze a bit, after I'm analyzing a bit the two, I see that I have here minus 3y, and I would like to have plus 3y. If I had here plus 3y, the y will eliminate when I add the two equations. Therefore, I need to make this equation 3 times as big as it is to have a 3y. So I'm going to multiply all sides of the first equation by 2, and I will get 3x plus 3y equals 15. I write the second equation below, always I go with both of them. And now if I add the two equations, I will get 9x equals 3y minus 3 will give me 0 equals 18. And if I divide both sides by 9, I will get x equals 2. I substitute x equals 2 into, I think equation 1 looks simpler, so 2 plus y equals 5. Take away 2 from both sides, therefore y equals 3. So my solution is x equals 2, y equals 3. I check by substituting into 1, x plus y equals 5, correct? 6x minus 3y gives me 12 minus 9 gives me 3, so that's correct too. So in some cases, I will need to look and multiply one of the equations by a number so that it matches the other coefficient from the other equation, and they will eliminate when I add the two equations. My last example is related to this system of simultaneous equations. X plus 2y equals 8, 2x plus y equals 7. Now, if we look and we try to eliminate, for example, y, it doesn't really matter, see the coefficients are kind of symmetric. So if we want to eliminate y, I will need to make this one twice as big. So if I multiply all terms of the second equation by 2, everything by 2, both right-hand side and left-hand side and right-hand side for the second equation, I will get, I copy the first equation, always go with both equations. If I multiply the second by 2, I get 4x plus 2y equals 14. Now see, I still can't add them because all coefficients are positive. So if I add them, I get 4y here. Therefore, the idea is to subtract them, because if you subtract them, you get 2y minus 2y is 0, and y disappears. I try avoiding subtracting, but instead I will multiply the first equation. I multiply everything by minus 1, so that I change all the signs, and then I add. So multiplying by minus 1 and adding is the same as subtracting. Therefore, I will have minus x minus 2y equals negative 8. That's my first equation. And the second is 4x plus 2y equals 14. And I chose to multiply the first one and not the second because I have less number of x's here. So when I'm adding here, I'm ending up with a positive 3x. It doesn't really make a difference, but you try to make your calculations as short as possible. So when I add both sides, I get, from the left hand side, I get 3x minus 2y plus 12 disappear, equals 6. Divide by 3, so x equals 2. Substitute x equals 2 into, well, it seems to be now that here number 2 is simpler, but it doesn't really matter because I have the y here. So I substitute into 2 and I get 2 times 2 plus y equals 7. 4 plus y equals 7. So y equals 3. So my solution is x equals 2, y equals 3. I will check by substituting both into the first equation. X plus 2 times y equals 8. That's correct. 2 plus 6 is 8. Second, 2x plus y equals 7. 4 plus 3 is 7. So that's correct too. So this one is the elimination method. I'm looking at having in the equations one of the unknowns with the same coefficient, different signs, so that when I add both sides, one of the unknowns will eliminate, will disappear. And from two equations with two unknowns, I will end up with one equation with one unknown that I can then solve.